give you a little brief here on some of the common inferential methods. But I know, like I've said, you should be have covered some of them in the different modules that you've covered. So the following are some of the standard procedures that you can use to make statistical inferences. One is what we call hypothesis testing, where you use a representative sample to assess two mutually exclusive hypotheses about a population. So statistically significant results suggest that the sample effect or the relationship exists in the population after accounting for the sampling error. So if your hypothesis, if your uh, if your null hypothesis was that uh, long distances do not actually contribute to uh, maternal death. Then if you do your sampling and uh, eh, after your research study, you should be able to make and understand from your study whether there is a relationship between long distance and maternal mortality, and therefore you conclusively make a decision and state whether your null hypothesis is right or it is wrong. Another inferential method is what we call the confidence intervals, or what most people in mathematics call as the CI. So the range of values likely contains the population value. So this procedure evaluates the sampling error and adds a margin around the estimate, giving an idea of how wrong it might be. So most times you see the confidence interval, you can be able to see that at a confidence interval of 95%, whether uh, uh, there is significance in your area of study. So, for example, if you wanted to understand whether urban or place of residence is responsible for institutional delivery or for mothers to take contraception, you should after doing a confidence interval, it should be able to estimate for you whether uh, place of residence is significant to contraceptive use. The third procedure or standard procedure you can use to make a statistical inference is what we call the margin of error. And here you are comparing similarly, it is close to using the confidence interval, but for it is usually for survey results. For example, if we did a population survey to establish how many people live in a particular area, then the margin of error, if it is calculated and it is negative 0, for example, negative 5% to positive 5%, then that margin of error is insignificant. However, if the margin of error is above 5% and negative 5%, then it is very significant and it would mean that there is a particular problem somewhere. Last procedure is what we call the regression modeling. And in regression modeling, we're saying it's an estimate of the process that generates the outcomes in the population. So in regression modeling, you're actually trying to understand the odds. For example, if the odd is 2, it can be able to define for you if you wanted to understand contraceptive uptake among using sex, for example, among male and female, you should be able to understand if the regressional value odd is 2, you should be able to understand that the odd of females using contraceptives is twice. So meaning that the chances of a female using a contraceptive is twice a male. Or if you wanted to understand whether the level of education affects contraceptive uptake, then using the regressional modeling, you can be able to generate the outcome. Odd one would mean that uh, odd one against zero would mean that women who are, or male, or people who are educated are less likely to use uh, uh, a particular contraceptive more than the others that are not. So this is how you, likewise, you can apply this inferential in trying to understand the demography of the population. You can help it to understand the chances of susceptibility to a particular disease. For example, if you did a regressional modeling on, malaria death, then you should be able to ascertain the risk at which either younger people or youth or children or elderly people can succumb to malaria. So we want to look at the approaches to probability. That was a hint or a brief into the aspect of statistical inferences. Now,